Welcome to January 25th LeetCode Challenge, Valid Mountain Array. Given an array of integers called array, return true if and only if it is a valid mountain array. Recall that an array is a mountain array if and only if these following are true. The array length is greater or equal to 3. Right? It has to be a size of 3 for it to be a valid mountain array. There exists an I with such that I is greater than 0 and less than the array length minus 1, such that these two are true. So we know that the array of index 0 is less than the array of index 1, which is less than the array of index I minus 1, which is less than the array of index I. Meaning that we have a certain index I, say here 5, or 0, 1, 2, 3, 4. So the index is 4 here, say the number value of 5, where you have I0 is less than index 2, 1, less than index 2, less than index 3, less than index 4. And once you get to I, any I greater than array of index I is greater than array of index I plus 1, all the way to array length minus 1. So you know that index 5 is less than the index of 4, and this is less than that, then this is less than that. So it's strictly increasing and strictly decreasing. That's what you define as a mountain array. As opposed to this example down here, you have a plateau, which is 3, 3, where both values are the same. Therefore, it's not increasing nor decreasing, so therefore it's not a mountain array, so therefore you return false. So the first thing you want to know is some examples. You have two values in here, which automatically rules this this if and only if statement out, because it's not an array greater than 3 or equal to 3. Here, this passes that. It has an array equal to 3, but you have two values that are the same connected to each other, so therefore it's a plateau. So let's say you have I equal to 1, I plus 1 is equal to 5, so therefore you have a plateau of 5, 5 here, which returns false. However, this example is true because you have 0, which is less than 3, right? And then you have everything subsequently being less than itself. So 3 less than 2 is less than 3, 1 is less than 2. So that's the idea. Constraints array length is between 1 to 10 to the 4, and array of I is between 0 and 10 to the 4 as well. Do we have any, do you want to click on the hint? Yeah, let's do it. Keep track of monotonic in increasing, decreasing order. You just need to be able to determine the start of the value of the mountain from points onwards. It should be the valley, no mini hills that you should, after that. Use this information regarding the values and come up with a straightforward solution. Well, I mean, that's the idea. It doesn't really help me at this moment, but I think we could actually pull this off using a single pass algorithm. I mean, there are some solutions. I think we use 2 pointers to kind of keep on moving forward until you reach a high value, and then restart the pointer and move it again. But I think we can use this doing a single pass. All right, let's go through some intuition behind that. So I guess if you just pretend like you're walking up the mountain from left to right, you keep on going until you strictly increasing until you reach a point where you don't know if it's a peak yet. And then you step down, like, oh, okay, now you want to assign that to be your peak, right, or your I location, and everything after that should be strictly decreasing, right? However, if you just reach a plateau, you automatically just return false because you know that that's not the case. So let's walk up the mountain from left to right until you can't anymore, and then it has to be a peak. Therefore, you walk down to ensure that the peak is not the first or last element. And then you want to walk down it until you reach the end of the array, and then it's valid, right? Otherwise, if it fails any of those type of steps, therefore you just return false. All right, let's go for a single pass. So the first thing you want to do is find the size of the array. So let's call this n equals the length. Assign that to be the length of array. And then you want to find the index, which we can assign that to 0 for the moment. Index, so n is the size of the array, I is going to be the peak index, but we don't know it yet, so we just assign that to 0. So we're going to walk up the array. So to walk up the strictly increasing, we'll do a while loop here. So while I plus 1, let me just put that together just to make it look a little nicer, is less than n, and the array index I is less than the array I plus 1. So we know that, let's see, the index of the array has to be less than the size of the array. That's obvious. So that's going to make this statement strictly true when we're inside our domain of the array. And that we keep on walking up the array so long as the value of index I is less than its previous value. So when that's true, we are going to increment I. Right? We're going to take each step going upwards by 1. So however, when we reach a peak with this, either we exit our array or index I no longer becomes the highest value. Then we will reach a peak, and then when we exit, so we either reach a peak or the last value, right? So if I is equal to 0, so that means that we haven't changed our index position, then we know that there's not a lot of values inside our array, so we could return false. Or if index I is equal to n minus 1, which means it's the end of our array, n minus 1. That means that we walked straight through, so that means it's strictly increasing all the time, and therefore we want to return false. Alright, if it's not at the end of our array, nor is it not the first element, if the index is not the first element, or the peak is not the first element, nor the last element, that means it's somewhere in the middle. Right? It's somewhere in the middle. So notice how we have less than sign. So even if we have a plateau, it wouldn't even go to here. So next thing we want to do is, I'm just going to put some comments in here, walk up. Let's see, peak cannot be first or last index. And then we walk down. Right? Now that we have reached our index where it is the highest value, ideally we should do this another while loop walking down. So while I plus 1 is less than our length, and the array at index I is now less than the array of I plus 1. If that's true, increment I by 1, and then return I equals I minus 1. So we keep on incrementing index, and then once we, as long as this holds, that means that we always reach to the end of the array, and then once we do, we just go find the element I. Down. We finish we just walk all the way to the end, strictly decreasing, and then we just return the index I, which is equal to n minus 1, right? Run the code. Let's submit it. Excellent. There you go. Wow. Runtime isn't very good, and neither is memory storage, but time complexity is big O of n, because we have a while loop here where n is the length of the array. Space complexity is big O of constant space, because we store everything inside a variable right here. So yeah, that's pretty much it. It's a quite fun one to do. Yeah, there you go. Have a great day, guys.